I hope you're able to see my screen. Are you able to see my screen?
No, ma'am.
No? PPT? Someone just said yes, ma'am. Okay, let me try again. Is it visible now? Okay, thank you. See, I just don't want you to keep on coming. Once you've logged in, please, I'll not be admitting again. If I try to switch from one screen to the other, what happens is the system gets stuck. So I'll not be able to continue. That's the reason. Whoever your friends are, please ask them to log in now only. So last class we started with process models. This is what it happens for me. So what is a process model? Yeah, can read it out. So before going to soft, let me on the recording. 75 students, so I think I can start now. Before understanding software Before understanding software process model, we have to understand what is a software process. Now, what is a software process? Software process is a set of activity which involves what? Developing a software. And as you know, there are four steps in software processes. What are they? First is requirement specification, second one is design, third one is development, fourth one is testing and evaluation. Okay. So in order to come achieve the software processes, what we have is or how do we achieve this or how do we do this? We use a software process model. It is a representation of the process, or it gives a description of processes from a particular perspective. So how do we achieve this? How do we achieve these four steps? That is specification, design and implementation, yes, validation and evolution. How do we achieve this? We achieve this through a software process model. Now there are different software process models. One of them is waterfall model. This is what I taught you in the previous class. This software, the waterfall model, is a plan driven model. So I'll explain to you what do you mean by a plan driven model. The next one is incremental development. Then you have something known as reuse oriented software engineering. You don't have it now, but this is one of the most of the major things, or major softwares are developed using reuse oriented software engineering. Nowadays, I hope you have heard the term agile. Have you heard agile programming? Okay. I mean, you're new to software, that's why you feel this, but as you go, you will see these, or you will learn about these terms, agile methodology or agile process development. Okay. So, what do we mean by model is model is a procedure or a technique which allows you to develop a software. Simply haphazardly, we don't develop a software. That is, first thing is to develop a software, we follow four steps or processes. How do we follow these processes? There is a procedure for that, that is known as process models. There are a number of different process models. One of the oldest methodology is waterfall model, then comes incremental, then comes reuse. So ma'am, everyone are going to use reuse or plan driven now recent. See, we can't say that. You learnt about different types of software products, right? Or software like embedded system, mission critical applications, or Android apps, something like that. So you have different software applications. So different types of them and different scenarios wherein we apply. So based on the type of software you are developing, we'll apply the appropriate model. But whatever software you are developing, please understand, if it is mobile app, if it is mission critical, if it is a OS or system program, it will have the four activities. Okay, I hope you all know what are those four activities. Yes, so you know all those four activities, you apply these four activities in a way, or a technique is used. That is what are these techniques called software process models. Fine with this? So what is this waterfall model? Waterfall model is a plan driven model. Now, I will give you one best example for this. Okay, some people are like, whenever they are doing a job, what they do is they will analyze everything, top to bottom, when we will finish, when we will start, what are the drawbacks or what are the problems, everything they analyze, they then start. Okay, and because they have planned everything, they can complete. Do you agree with me? Some things are like that. Some people are very well planned. They would have planned 1 week, I will finish this. Second week, I will finish this. And they go on. What and all to finish, what and all they are expecting, everything is planned. That kind is known as waterfall model. Some people follow incremental model. What do I mean by incremental model is, yes, I don't plan ahead. I start with something, I finish it, and I take up next. So now, can you tell me what are the drawbacks and usefulness of if you're following these two procedures? You're planning everything ahead and completing it. Some things, you do one job at a time, take up that job, finish it, then go to the next job, check it up, finish it, like that. You don't plan ahead. That is known as incremental development. When you're doing this, you face some issues, right? Or what are the drawbacks, or what are the issues when you're doing this? Can someone tell? Yes. Yeah, tell me. See, if this class, if you are not interacting, then you will be sleeping. Okay. The process is not visible. Yes, Ishita, what does that mean? Fine. Problem is this subject you have too early within your engineering career. So it takes some time for you to understand what are the concept and what does it mean. See, if you plan everything ahead, good, good. Okay. See, both of them have their pros and cons. Let's say some student, a rank student, he's done everything planning and he works out. Fine. Now, what are the advantages of having this waterfall model? And what are the disadvantages? See, when we take up this waterfall model, what happens is if we keep on planning, you will be telling, no, he just only does planning, but he does not work. Yeah, that is what happens. You keep on planning, but you will not start the work. And planning only will take up so much time. There will be no result visible for the end user or the customer. Let's say, for example, I am doing the developing a process or a product, software product using waterfall model. My 1 month time is fully spent in planning. But when the customer is very eager to see what is the outcome, then is there something to show the customer? This is what has been done. No, right? When will the customer be able to see in the waterfall model is at the end result. So what happens is the customer does not know what is happening till the product is released. So this is one of the drawbacks. Fine. Let's take for incremental model. The advantage is the same thing in incremental model is here you don't plan everything and then start. You take up some small job in that and you finish. Now, by the end of 1 month, you will rather than keep on planning in waterfall model, here you will have something which is ready. May not be full, but a part of it, 5%. Now, when you develop it and show it to that to your customer, the customer might be very happy or if it is what he is expecting. Also, if he is not expecting that, when you show him, he will say what is wrong, what is right. When you do that, you will know that what to do next. Whereas in waterfall model, what happens is you will not get the feedback from the customer till the product is released at the end. So both have their pros and cons. So you cannot tell which is best. Okay, like some students study just 10 days before the exam. Some students plan ahead and start from the semester starting. Now both of it has its advantages and disadvantages, right? We can't say which is right, which is wrong. It depends upon the person who is studying. Okay, so similarly is these models. Am I clear with this? I will explain more about these models. So first one is waterfall model, which is what you learned. In this waterfall model, first we come with the requirements, then come up with the design, then with the implementation and unit testing, then integration and system testing, and then operation and maintenance until the product. The customer, once he gives the requirement here, he will be able to see the product only during operation and maintenance. During any of these phases, he will not be able to see any of the product what is being developed. So this is both advantages and disadvantages. Advantage is you can, because you are planning ahead, you will know what are all the risk involved. Okay, when you come up with this requirement phase, fine, when you are doing with this requirement phase and design phase, you will know how the system will be developed, what technology is being used, everything you will be noted and risks are calculated. Fine. But only thing is, yes, everything is calculated. You will know phase, and there is a process involved, one not after the other. And each of the module is intertwined or dependent upon the other. That is, this design is dependent upon requirements, implementation is dependent upon a designer, like this. Fine. So here each phase will be completed and only then you can go to the next phase. Suppose I'm in requirements, I cannot jump to designer while I'm in requirements. Fine. Only thing is I was seeing your friends' messages. Someone has sent there is no such meeting present. I mean all of you have joined, right? I don't know who that person is. Okay, fine. Problem is, see, when I'm doing when I've switched my app to the PPT, I will not be able to see again. That is what I said. It is loading. If I've not let you in, please wait for 2 or 3 minutes until I go back to my Google Meet. Fine. I hope you understand what the issues here also, what I am facing. Yes, I know that your network goes off and again you have to join all the time. But if I keep on switching, I will not be able to show my presentation. So I request all of you, next time if you face it, please wait for 2 3 minutes. I will let you in later. Okay. So here, one you can until a phase is not completed, you cannot go to the next phase. That is why it is called water model. After one phase, the other phase is taken up and it completes. You cannot go in between or you cannot jump in between the phases here. Did you understand this? So one has to complete a particular phase to go to the next phase. Now I want you people to write it down. Take a rough book and write down this picture, waterfall model, and write this. In software engineering, I want to tell you, no matter how much pages you write your explanation, a picture or a figure with respect to that concept is a must. Almost for every concept, you will have a picture like this. So you have to by heart that picture and you have to write. If you don't write it, you will not get marks. See, and the other thing is, once you have by hearted this picture, you can write the concept. You need not have to I mean, once you have learned that picture, it will be easy for you to explain. Here in the waterfall model, you can explain that you come to the only one after one phase, you will be going to the next. That is why it is known as waterfall. You cannot jump between phases. That is, from requirements, you cannot directly go to implementation. It has to come after system design or software design. That too, this thing should completely be, I mean, the phase has to be completely finished for you to go to the next phase. So this is about waterfall model. Any doubts? I want you to write this picture fast. Okay, now I'm not got any request. Finished writing? Okay. Problems with this is partitioning of the project. Problem with this is inflexible partition of the project into distinct stages makes it difficult to respond to changing customer requirements. One of the most important drawback is it cannot it is not flexible enough, or it cannot take into picture the changing needs of the customer. Let's say for example, after 1 month or 1.5 months of the project starting, when they are working on the implementation phase, the customer asks for some changes. Now, at that time, you have to go back to the requirements document and change the requirements. So, at those cases will not be possible in waterfall model. Sometimes you can change, or up to some extent you can take some changes. But if your system is constantly changes, or your customer needs are changing, then this model is not suitable. Because if you change your requirements, then again it should change the design, then it should change the implementation. You cannot start with the changes only in the implementation phase. So it again involves going back to the first stage and taking up the requirements changes. So that is the reason why this waterfall model is not suitable for projects which involves changes in the customer requirements. Next thing is it can be used only for large systems, or systems that take lot of time to develop. It means to say, let's say for example, your project deadline is for 1 month. You have to complete a project within 1 month of the time. Now, if you use waterfall model, if you say I will take up it in steps wise, one after the other, it will take too much of time. See, for planning, for requirements design, if you take 15 days, for implementation and testing you will have only 15 days left, whereas it is the most of the time that is taken by your system. So this system is not useful for very small projects. Only in case of large projects you can use a waterfall model. Fine. So these are the problems. Advantages is you can plan ahead. You will know what are the risks and problems that will be faced, and you will know the processes that is followed. That is the documentation, how it works. Everything will be known in advance. So this model has its own benefits and drawbacks, and it is mostly suitable for large systems, and it is not suitable for systems which are wherein the requirements are constantly changing. Fine. Any doubts? Any doubts here? Yes, please respond. 82 students, none of you are talking. No doubts at all, or you have not understood at all. Second point in this slide, sir. So it is used for large system engineering projects where a system is developed at several sites. That is what you are asking? Ma- Karthik MR. Okay. See, that is what I said. If your project is very big, okay, it is a 1 year development project. Pros of waterfall model is, yeah, let me finish this. Karthik's questions, I will take up first. See, the if you are developing a very large project, that is a project which takes for 1 year, I say that is a large project. A project which gets to be completed in a month's time, I say that is a small project. Okay, did you understand what do you mean by a large project and a small project? Large one is something which is complex and it takes time span is more. Small is one which is not that very complex, which is completed within a short time. Okay, so if you're doing a large project, then this is suitable. Why? Because if you have a large project and a complex project, you will note down everything. Requirements, what are the requirements, you will design it. Like you will take 1 month for requirements, 1 month for design, you will take around 6 months for development, and another two months for testing and for deployment, like that. So you can do phase after phase like that, because you have time to do that. And because the system is large, what happens is you will note down everything. Now there are 20 requirements, means you can simply not haphazardly start off, that you will see in the later next model. You will write down all of them and you will design it properly and complete it. Are you getting my point? So this is how it goes. But if you are, let's say for example, if it is a very small project, in the sense something in 1 month, if you are doing that, there if you are taking requirements first 1 week, then design 1 week, you will be left with how many weeks? Then 2 weeks. Then within that 1 week development and 1 week testing and deployment means, will there be sufficient time? That is 1 week of implementation time sufficient? No, right? Yeah, think about it. Fine. Now, for Karthik, I can give you one more example. Let's say I want to build a building or a house, okay? Very through duplex house like that. For that, will I not go to architect, then properly plan everything and do? Suppose I'm building one single room, fine, extending it, or I don't want to build, I'm doing a single room within a some plot or something like that. One room and for something like that, for a storehouse or something like that in a plot. So during that case, do you go for what a architect plan everything and do? Why? Because that one room is a very small thing, but whereas a building, what you have done is a very complex thing. Did you get it? The second point, Karthik. Okay. Now, Pranav asked, what is the pros of waterfall model? Pros, I can say this. This is the first point I said. It is very well suited for a complex system or a very large system. Like I said, everything is planned properly. You go phase after phase. Fine, Pranav. Did it explain the pros also? So the next model is incremental model. Now you can get to understand. In incremental model, we don't do go one after the other like waterfall model. You know, see, in any model you take, always there are four processes: specification, design, development, and validation and evolution. but how it happens is what we differ. In incremental model, what happens is we don't go one after the other. The processes happen concurrently. Concurrently means, suppose a product has certain n number of features. We don't develop every feature specification. We don't come up with a complete specification at once. Okay, we don't go take all. If there are 5 requirements, we don't take all the requirements first and then go to design. No, we take first design, we start with the requirements, we design, okay, and we develop, and we test it. Meanwhile, there may be another requirements which come, we develop it and we validate it. So this goes on, like in between also you can go take on requirements and start developing. So once you take a requirement, develop and validate, you will get an initial version. Now, this initial version is not the complete product, but it requires only one or two. It has only one or two of your requirements. This initial version. Fine. So once you develop an initial version, to this again you take some specification, you develop it, you validate it, you take two or three, then you develop, come up with some intermediate version. Now, see, once you come up with the initial version, what happens is, the main advantage of incremental model is, this initial version you show it to your client or the customer. Did you get it? So this initial version, when you show it to the client, the customer, he may say, "Go ahead. This is what I want." So this will give you a feedback. He may say, "This is not the one I want it in some one way." It will give you a clear understanding of the product, which will allow the developer to get the feedback from the customer, and the customer also will feel safe and happy, or something like that. What he wants is being developed. Whereas in waterfall model, what used to happen, the customer would get the product only at the end, but here it is not like that. He will get to know the outcomes of his product at different stages. So with this version, one version, we will see like this. Then we take the specification, we come up with the intermediate versions. Then yes, again we develop the specification, come up with the final version. So in incremental model, all these activities happen concurrently, and development is not completely dependent upon a specification. Okay, what you are developing, the requirement is available, that you will start. Did you understand? Any doubts, sir? I will put the same slide. I want you to understand this concept. I'll give you 2 minutes, sir. Okay, guys. Any doubts? Anything? Did you understand at least? I won't say you will understand 100%. At least, did you get the basic idea or difference between this and the previous one? Okay. So, what are the pros and cons? The cost of accommodating the now. There are three advantages. I want you to read it out. Yes. Did you read it out? I'll ask someone. Any doubts in this? This I've already explained. This slide. First one is cost of academic. The advantage of waterfall model was accommodating changes. So here you can whatever the customer says. See, first initial version you developed. You the customer says he wants so many changes. So here this can be those changes can be done with less effort and less cost. That is the advantage. Here you can get customer feedback, which is not possible in waterfall model. Here you can rapidly develop and deploy the software. See, when you're using waterfall model, you have to wait till everything is done to get one initial version. But here you can get an initial working version at less time. Fine. But yes, problems are there. What are the problems? The thing is, if it is this type of model is effective for small systems or very small projects, not very large projects, meaning that suppose I've taken a very large project and I keep on add these requirements. Okay, what happens is whenever there are changes, there will be no proper documentation of the system. Fine. And sometimes what you have already, if new requirements comes, might happen is if it is a very large system, it may require changes to the already existing things. So that is one problem here. I mean, frequent changes. You only tell me if you are doing something, and every time I ask you to keep changing and do this and do that. Will you be able to? Maybe yes, one or two times it is fine, but it happens continuously. Will you like it? No, right? That is what it happens, and the system structure will not be proper. That is what we say, that it will degrade, the system will be degraded as new requirements are added. Let's say that house construction only, I will say yes, I don't want a plan architect. I did one room and bathroom. Tomorrow I will just say I want to extend it. To that I will add one hall. To that next again I will add another kitchen. Like that, if we go on adding to one room without any plan, will it not look absurd after some times? Yes, will it not actually? the structure of your house, will it really be good at that time? No, right? That is what happens to this incremental models also. If you keep on changing and changing, it will degrade the system. So this pros is, or advantage is, you can get the feedback, and you can take up the changes, and you will get an initial version of the product, so that you can sell. You will have some what cost. Okay, you will get some money associated with that, finance and everything. But if you but the disadvantage is, you will not have proper documentation of how the system is working, and as you add too many requirements, new requirements are added, it will degrade the system. Okay with this? Any doubts in this model? Yes. One second, guys. Ananya, I didn't understand the first benefit. Okay, in incremental. This one, Ananya, the cost of accommodating changing customer requirements is reduced. See, Ananya, if a new requirement comes here, let's say the initial version is developed, okay, then a new requirements come. Fine. What happens in incremental model? I will explain with this figure. Now I have an initial version. After that, seeing that according to the customer, a new requirements comes. Now, when a new requirement comes, we are not going to change anything here. We take the specification, we development, we validate it, we come up with a new version. Okay? Fine. It does not involve changing or existing any of the model, see, existing entities. But when we go to waterfall model, what happens is, if there is a new requirement, you can't add first of all. Okay, it is not allowed. But even if we try to add, when I'm in implementation or when I come here, what happens is, I have to make changes in requirements, I have to make in system design, I have to make in unit testing and integration testing. Okay, everything changes. So ma'am, then what do you mean by cost? Cost means, here, involved with, maybe I can say one cost is, people have to, more people resources have to be put to do that. Yes, is it not a cost? The time required will increase. Is it not that? So that is why we say that the cost of getting the adding new requirements, we don't say here there is no requirement at all. I mean, there is no cost involved. Yes, there is cost involved in incremental also, but it is less. But whereas in waterfall model, the cost involved is more. That is the comparison what we are doing here. Understood, Ananya? So it is a comparative cost. In incremental, the cost is less, whereas in waterfall model, the cost will be more. Any other doubts? See, in your exam, first problem, process is not visible. Okay, I will give you a one example. Let's take the house mm, construction example, real time example, which I gave. Now, today, this is something which I have seen someone encountered. See, they built a house, they did not use some plan. Okay, they wanted very simple, they thought very small, one bathroom, one hall, and one kitchen, or let's say one hall and one bathroom. Okay, they built very small one. Do you require a plan? Usually when you are building something like that, do you come up with a plan for that? Go to the architecture. Yes, Akshay. Yeah, if you're building one room and one bathroom in one empty plot, will you ask an architect for that? Design everything? No, right? So that is what will happen. So I will take this example. First year, when you are 20 years of age, you have only that much money, so you put that and you build one room and bathroom. After 5 years, you are earning enough. I want to extend it. You will think only thing is I want to add a room for this. Why I will go for a plan already there. You will extend it to one room. Okay, fine. Now, have you put any foundation or anything? Nothing. You have done everything. You know that. After 10 years, you are moving to US. You are in a very good position. Okay, you want to sell it. Fine. You will sell it to someone and you move on. Okay, the new person comes, he sees there is only one room and one hall and this thing. He wants to extend it to two rooms and he wants to add a kitchen. Now, but because already the building is there, he wants to know whether the foundation is there for the hall or for the room to extend it, or upstairs I want to do something. So can I do that? Now, is there a plan when you are okay, fine, he will do that also. Okay, someone he does, and he, after 50 years his son, he's expired or gone, his son comes into picture, he wants to extend it. Now, is there any process or a plan of how that house was built? Yes, Akshay. Now, if someone wants to build, after everything extension, someone wants to go to the first floor, will they have a plan? Will they know whether it will take that capacity or everything? No, right? Because you have done for 4 to 5 people have done so many changes to that, no one will know what has happened. At that time, the person who is constructing or making the changes for the fifth or the sixth time, what will he do? He will demolish, he will do a proper plan and come up with the building, isn't it? Right? Now, my example, will it not apply to the software product? Initially very small project, I will just start, then add something new to it, then add something new to it. If you go on and the person who has developed the product after three changes has left the company, fourth person comes, will he know what happened by the three changes which was done by the first person? What will he do? He will say, I will rewrite the product, I can't make changes to it is so much tangled. So did I explain your first problem now? Thank you. Shall I go ahead? Next you have is Bohem spiral model. Now Bohem spiral model, according to your textbook, people don't use it much. Actually, no. Oh, you have learning. This is the last spiral model. I will explain it and let you know. But this either waterfall model, incremental, or Bohem model will come compulsory for your exam. Last time Bohem spiral model was the one which came for your exam. So one of the model will come. Please prepare it. Write the diagram. Without the diagram, you will get one big zero. Fine. So let's go to this Bohem spiral model here. Here, this is a software process model. It has both the, I can say, somewhat it takes both the concepts of what your waterfall and uh, incremental, but here the product is developed in phases, like your incremental model. But only thing important in Bohem spiral model is it does risk analysis at every phase. So this is a process model which is more suitable for project wherein there are a lot of risks are involved. So here, if you can see, these are the spirals like this, circles like this. Each each spiral represents a phase. Okay, the different phases in the process software process development is given by this spiral. So the first spiral is nothing but the requirements. Second one is design. The third one is development and testing. The fourth one is evolution or something like that. So each of this spiral represents a phase of the software development. And this is in turn divided into four sectors. This is first sector, this part. Okay, this is second sector, this is third, and this is fourth sector. And always within the second sector there is a risk analysis in each phase of the software development. So you have a risk analysis in each phase of software development, which is one of the important factors in Bohem spiral model. So let's take for example here, I am determining objective and alternatives. So the first sector, let's say. So here the first sector is objective setting. So that is nothing but here objective setting. What does this objective setting do? It will identify what is expected of the this phase. In case of requirements, it will be like requirements are gathered. In case of design, the design, whatever design has to be done, it will be taken care of. What are the objective of the phase is determined by this one. Next, what you have sector is risk assessment and reduction. So this is first. Let's go to why is it? Yeah. The second one is risk analysis and evolution. So what we do here is now I know what is the objective, right? I get to know the objective in this phase, in this sector. Here, to achieve that objective, is there any problem? Or is there any risk involved? I get to know it in this risk analysis phase. And I will try to overcome that risk. How? By coming up with a prototype. What do you mean by a prototype? Prototype is means a model of the system. It is not the actual system, but it is so it is nothing but the model of the system. By developing this prototype, what is the use is it will let you know whether the system will be a success or not. Okay, so you will come up with a prototype here. So this is the second sector wherein you will do the risk assessment and reduce the risk. How? By coming up with a prototype. Next sector what you have is development and validation. Now, this is a sector which does the development and validation. Now, there is an objective which is given here. To achieve that, you will know what is the risk and come up with a prototype. The actual implementation of that objective is done within this development, and then you will verify it. So, this sector here, that is this part of the sector, will do the development and verification. The next sector here is this one. It will plan the next phase. What I want to do in the next phase will be given within this. Okay. So let's take for requirements first. In the requirements, in the previous phase, we will know after the customer requirement what are the requirements given or required. I will get it. Okay. What are the objectives? I will know this here. What are the risks involved in achieving this objective? I'll come up with the prototype of that requirements. Yes, how that concept will work of this requirement I will do. Next, I will plan for the next phase, maybe requirement or design. So yes, when I come up with this design next year, is I will come up with the objectives of my design. Then to achieve this design, is there any risk? And then prototype. Then develop that design. Yes, are you getting my point? So here actually we are doing the requirements after getting it, and I'm coming up with that requirements plan. So next again when we do, we will design it, we will develop it. It is nothing but after this we will development plan we will do, we'll plan and come up. So here each spiral represents one of the phase of the software process. Whereas sector gives me what there are four sectors, and the first sector is to determine the objective, second one to identify risk and resolve risk, the third one here is to develop and test, and the fourth one is to plan. So if it is in requirements, I will do all this. Here, every time I will take the risk analysis if it is in requirements, development, validation, or evolution. Every time we come up with a prototype. In case of requirements, yeah, what do we develop, ma'am? We come up with the requirements document. Then in design, we come up with the design. In actual development plan, we develop or come up with the coding. That is in this part, that is coding, and we do the testing part, unit testing, then integration testing, acceptance testing, and service is nothing but evolution. Again I will explain. A spiral model,
Welcome everybody to your
processes are
all-in-one C++.
represented in a spiral rather than the activities with backtracking. There is no backtracking here. Each loop in the spiral represents a phase in the process. There is no fixed phases such as specification or design. Groups are chosen depending upon what is required. What does this point mean? See here, it is not like only after coding or one phase is coding in one spiral, I do the coding and the next spiral I have development. It is not like that. In the same spiral, I can have a detailed design, coding, unit test, then integration testing. It depends upon how we want to develop the product. Okay, so loops in the spiral are chosen depending upon what is required. So based on a requirement, we develop the loops. Only the good thing or advantage is risks are assessed and resolved throughout the process. So whatever the risk in the product is, we identify at the earliest, we reduce or assess that risk and then go with the development. Okay. So I want you to read this. I will give you 2 minutes time. Excuse me. If any doubts, you can let me know. I want to have a let me have a glass of water and cup. Okay? Please read these slides and let me know. The same thing what I explained, it is text is here. Yes, any doubts? Can I move further? But your people are all sleeping or you're doing something else? Okay, I will take it as an yes. So where do we use that? Only in the risk-driven approach of development we use it. Practically, they say that they don't use it according to your textbook. I don't know much about that. But from your examination point of view, it is a very important question. Okay. Next topic is process activities. Yes, what are the 4 different process activities? Can someone tell me? Yeah, what are the 4 activities, process activities? Yes, thank you, Aditya. So you will learn more about these activities. First is specifications. It is nothing but getting to know. Yes, specification, development, valid. Uh, Kavya, after specification, you have design. Okay, specification, design and development, or development, design and then development and validation, and then evolution. Okay. Yeah, where is design went off? All of you have not taken up design. It is design and development. Okay. All of you remember that. Design and development. and then validation and evolution. One second. First step is requirement specification. Here in requirement specification, you have four things. First is feasibility study, then requirement elicitation and analysis, then requirement specification, and requirements validation. Okay, feasibility study is getting to know whether technically and financially you can develop a system or not. What do I mean by technically? See, the customer may ask something to develop, use this and develop a system, but it may not be technically possible. There are so many reasons. If he says to integrate two products, Apple and Microsoft products, and come up with something, okay, then technically you might know that is impossible to do because there are no APIs available or there is no software to do that. That is what in feasibility study you will do. You will check whether it is possible to develop such a product, or it is it is possible to use such a technology or not. Okay, next is financially feasible. Financially feasible means you would have quoted while asking the customer for a product, you would have quoted for some amount of money, right? So you will check whether here financially within that you can develop a product or not. If it exceeds, then you will not be able to develop. It will be a loss for you. So you will check in this feasibility study whether technically it is possible and financially also it is possible or not. How do I check whether technically possible? Technically possible, how would we check is by developing prototypes. Prototypes means the system, we will develop a system or a model of that system and see. Okay, may not be like complete model, but a prototype of that we will build and check and see. Fine. And for financially, there are so many tools wherein you calculate the cost involved in each phase and the total overall cost, and you will determine whether it is feasible or which is relatively cheap and quick. The next thing is elicitation and analysis. Here we develop the requirements from the, or we come up with the requirements of the system. So we talk with the stakeholders may be the customer, and discuss about what are the functionalities involved. So based on this, you will understand the requirements and come up with the requirements. What is required to do of your product. Simply see, it is not like simply the customer says develop me a web page. If he says, it is not the complete requirements. It is like you have to talk to him in your web page, how many users will be there, who will be using, all that you will discuss with the customer. So you will analyze the requirements. That is done in this requirements elicitation and analysis. Next you have is requirement specification. Now, yes, this customer says yes, the students are using, the students and the faculties are using my website. If they say in the statement, you will write down those requirements in detail, like how many students will be using it, whether remotely, or what kind of access do they have, whether they are a admin or non-admin, or if a student has to access, whether he should be any student can access, or from like from a particular college or a university. So all that in detail you will be specifying it in requirement specification. Okay. Next is validation. Validation means see whatever you have understood in analysis, you will write down in specification. Now, that thing you will give it to the customer or the stakeholder to check whether it is correct or not. Why? Because what you have analyzed and what you have written might be different. Each people will have their own way of understanding, okay, and explaining it. So, if we have written it wrong or if it is right, how do we know? That is done through validation. So, who will do the validation? It will be either a person higher up from the company or the customer. They will do the validation. A diagram for this is here. First is feasibility study, then requirements elicitation and analysis. Based on that, a requirement specification will come. Now here there is a feedback in each phase. See why, I will tell you. Now there is a validation here. Now in the validation there were some changes. So you can go back to the specification and your analysis will also change. Okay. So when you come up with the elicitation and analysis, there is system models, that is nothing but prototypes, not the actual system is developed. Requirement specification, user and system requirements will come. Fine. So at last you will have a requirements document which is validated by the customer. Okay. Next, what we have is the next phase of software processes, design and implementation. In design, what we do is we take the requirement specification and we come up with a executable system. Here, executable system does not mean that coding. It is like a plan, your architectural diagrams like that. This design is a plan. Using this plan, we later come up with the executable code. That is nothing but implementation. Design is nothing but a executable system or a plan, whereas implementation is the actual coding. So in design, what do we do? Actually, design processes are divided into like this. You have something here. So design involves there are more to this, but four things you can think of is architectural design. This architectural design gives the overall design of the system, or the overall structure of the system is given within the architectural design. Interface design tells how these different system components interact with one another. Component design will tell how each of the component is in turn work. Database design is wherein the data structures that are used in your product is described. Okay, let's take for example, ma'am, I did not understand anything. Let's take for example, I have a student website. Yeah. So in a student website, there are so many things, right? Let's say for college, you have one component. For student there is another component. For faculty, when let's take your VTU website, now for students only there is one login, for faculty there is one login, there is for general users there is one login, for college there is one login, right? And there is something like result, UG, PG, like that. Yeah, the overall design of the VTU website is given within this architectural design. This architectural design will show all the components, student, UG, PG, faculty, college, say what which area you belong to, Bangalore region, and all that. Now, so that is described in architectural design. In interface design, will tell how all these components will work. That is how student component within this will interact with the college, how college will interact with with the region. So the interaction between all these components is given within interface design. Yeah. Next we have is component design. Now there are overall components or subsystems you identified. How each of these components work. That is how student component work, how college component works, how different regions, faculty, all of them work. It is given within the component design. Next, you have database design. Database design will tell all the data. What is the data involved within your system? Maybe student details, faculty details, college details, result, all that. So, how is all that data stored in the database? How who can access what? What are the security? Everything is given within database design. So design actually involves the overall design of your system or the product. Fine. So that is what we have. In design inputs, we have platform information, requirement specification, data. Then we come up with the architectural interface and component and database design. These are the activities which we do. We come up with the design of these things. And what is the output of this design activities? Yes, with architectural design, system architecture, we get it as output. In database design, database specification is the output. In interface design, interface specification is the output. In component design, component specification is the output. Yes. The third step is software validation. It is called V&V, verification and validation. Verification means what you have done is correct. You are testing it. Validation means you are checking it is working properly, but you want to check with the customer that is what you wanted. Okay, according to you, it is correct, but that is what the expectation is. That is nothing but validation. So here in verification and validation, we show whether the system conforms to the requirements of the system customer. It involves checking and reviewing processes and testing. You have something known as unit testing, system testing, integration testing. I've told you about that. In unit testing means those who are the code, people who develop the code, they do the testing. System testing, overall system is tested. Integration testing, when the different modules are combined together, we check whether the execution is happening properly or they are working properly. That is known as integration testing. Then you have something known as acceptance testing. That is the customer checks what the functionality is implemented is what he wants. I think this I had told you in earlier classes, different types of testing. So validation and verification. Yes, you test the component, then you do the system testing, and then you go to the acceptance testing. If there was some problems, you go back to the component testing and check it, and you can go to acceptance testing. Development testing is nothing but unit testing. System testing, overall system. Acceptance, that is checking with the customer whether it meets his needs. So this is how it happens. When you come up with the requirement specification, the acceptance test plan come is what you get. In this acceptance test plan, there will be like what is expected, what is the input, and what should be the output of the system. In system specification, when you come up, the integration test plan is what is the outcome. When you design, the subsystem integration subplan comes into picture. In detailed design, you will have module and unit test code. So this is how it happens. You come up with specification, design, detailed design, you do the module and unit testing, then you integrate it, subsystem integration, system integration, acceptance test, and the service is ready. And during each plan, that is, during this phase, you come up with this is the outcome. During this phase, this is the outcome. So, while doing this testing, you check whether this plan is correct or you test based on this one. Here also integration testing, you test based on this outcome. Let me finish this. Okay, I will let you know. Okay. Evolution, like I already said, changing software needs will require the system to evolve and change. Fine. There is an event as fewer and fewer systems are completely new. Okay. So here, so you come up with the new requirements, you assess with the existing system, propose the changes, modify the system, you get the new system, then to the existing system again you check, and if you want any things you keep on adding. So this is how it is. See, first time you come up with the requirements, okay, and then you keep on add and modify, you will get a new system. Now assess the new system and you keep on again, you can add requirements to it. This is nothing but system evolution. This I had explained to you in the previous classes, that's why I went faster. Ma'am, this was okay. Any doubts or anything you did not understand, or you did not understand anything at all? No, I want a response. No doubts at all. Come on. So, any out of the 83 students, no one has any doubts? So, tomorrow, if I ask you to present this, will you present it? Okay. I'll do one thing today. I will share this PPT and your recording today, sure. Yes, Pranav. The reason I went in the last requirement specification a little bit fast was because I had already done about it. But okay, I will do one thing. Today, I will give you this PPT and this recording. Fine. Process activities. Not shared from so many touch time. So, but today I will make it a point. I will share this PPT and the video with you people. Okay. I want you to go through it once. And next class, what I have is on Saturday, right? Fine. Saturday, I will give you a overview of that, what I did. Will it be okay, Pranav? See, if you're not a little bit preparing, or if you don't get an idea, what happens is no matter I explain it every time, you will feel it like Greek and Latin, or you will forget. Okay. So I will send you this material. I want you to go through it, and Saturday I will devote 15 to 20 minutes of my time on this topic. Will it be okay then? But I want from your side for you to put some effort. Now you know at least 20%. You can read it, right? Okay, we'll do that then. Anyway, you have a holiday tomorrow. Friday, you don't have my class. So Saturday is the next class. You can go through it. By then, I will share. If not today, tomorrow morning, sure, I will share you the material because I have, again have class and examination duty. So maybe it will be evening. Only after evening, I will be able to share this presentation in PPT. Anyway, I got your class email ID also, class group email ID. So I will send it across to it. I will put in the Google Drive and share the location with both A and B section. Will it be okay? Both all the videos and this PPT I will share by tomorrow morning. If I don't share, someone can remind me. Fine, I will share this. Okay.